Hello! In this video we're going to be talking about math traps. The SAT is a test that tries to trap you, and they do have many problems that are designed around common misconceptions many high school students have. So fear not, we're going to talk about those misconceptions so that you know the traps, and then we're going to give you the proper ways to do it, or the tricks, so that you can do these problems easy as pie. So the first trap is a percentage trap. Many students think that it's okay to add or subtract percentages, and this is not the case. So while it might be tempting in a problem such as what I'm about to make up, if I gave you $100 in stock, if it went up 10% in year 1, down 10% in year 2, it might be tempting to think that you have $100. But the fact is you don't. And unless you actually do the process correctly, you're going to have a hard time getting to the right value. So let's take a look at a problem dealing with percentages and learn how to do it correctly. So this problem says that Billy bought a bike at a garage sale for 50% less than it was originally sold for. After fixing up the bike, Billy sold the bike to his friend Tom for 30% less than he had paid. The price Tom paid was what percent less than the bike's original store price? So to do a question like this, we need to start with a number, a starting price. And since we don't have one, we always want to use the number 100. So this is the main part of the trick. Start with the number 100 when you don't have a value to use. Now we need to work through the percentage changes one at a time. We don't just add 50 and subtract 30, or we'll get the wrong answer. So we start with the number 100. If we decrease 50 from 100, or 50% of 100, we'll be at 50. Now the next step is the step that most people make a mistake on. We now have to take our 50 and increase it by 30%, not 30. So you don't add 30 back to 50, you increase 50 by 30%, which you would get by multiplying 0.3 times 50 in your calculator, and you get 15. So increasing 50 by 30% would be taking 50 to 65. So the net effect is that we are 35% less than the original 100. So the right answer here would be D. Again, what we don't do is subtract 50 and add 30, saying minus 20. What we do is start with 100, do our percentage changes incrementally, and remembering that a percentage change, aka the 30% here, is not going to be 30 unless you're doing it off of the first number 100. So let's take a look at the next trap, which is weighted averages. Again, the tempting trap here is to average averages. So if I said that you got a 90% on 3 tests and an 80% on 2 tests, and I said, but your average score, it would not be 85. You can't simply average 2 averages. So in that question, we would do, if we had 3 tests at 90, it'd be 3 times 90, or 270. And 2 tests at 80 would be 2 times 80, 160. So our combined score would be 430. And to get our average, we would just divide by 5, which would give us an 86 average, not an 85. So the trick here is to use tan charts, or total average and number charts, to do these problems. Now, that's just a complicated way of saying you have to work in totals. You have to get totals, and you can add those, and then you can find average by adding the totals and dividing by how many things you have. So let's look through this problem to understand this better. So if we average 20, or Jimmy averaged 20 points in his first 3 games, and he averaged 30 points in his last 2 games, what was his average score for all 5 games? Now again, it's tempting to say 20 plus 30 is 50 divided by 2 is 25, and pick C, which is incorrect. Now using intuition, we realize we have more 20s than we do 30s, so our answer shouldn't be any higher than 25, and we know it can't be 20, so we can use the process of elimination to get to the right answer, B. Now to do this question correctly, we just have to work in totals. So 20 times 3 is a total of 60 points for his first 3 games. 30 times 2 is a total of 60 for his next 2 games. Now we can make the final calculation. His total points scored was 120, the total games played was 5, and we have 1 division to make. 120 over 5 gives us that average score of 24. So again, when you see average problems, do not average the averages. Get yourself totals, and then divide by how many things, tests, games, whatever you're counting, how many you have, and you'll be able to get your overall average score. Our third trap is average rates. Now these don't show up that often, but they're a question that you can spend a lot of time on, and if you don't know how to do them, the common misconception is very broad, so we want to touch base on this. You cannot average speeds. So if I said that you drove 30 miles to work and you drove 60 miles home, or 60 miles an hour home, excuse me, what was your average speed? Most students would say 30 plus 60 divided by 2, 45. because you don't have a distance, so it seems like, well, I'll just average the two speeds. That is going to give you an incorrect answer. So we know that 45 is wrong. Now again, using some intuition and trying to just go with an elimination approach here, we know that since he drove slower at 30 miles an hour, we'd spend more time at 30, and thus our average speed should be below 45. So we know the answer really can't be anything but A or B. Now to do this question correctly, much like the percentage questions, we need to add a number in here. We don't have a distance, and it doesn't really matter what distance we pick. The answer will be the same regardless, but we want to pick a nice, easy distance that's going to allow us to use our distance divided by rate equals time equation. So we're going to pick a distance of 120 because it's a multiple of both 30 and 60. So in the first part of our trip, driving at 30 miles an hour, 120 divided by 30 would be 4 hours. In our next part of the trip, 120 divided by 60 would be 2 hours. So our combined total distance is 240 miles. Our combined total time is 6 hours. And so our average speed is 240 divided by 6, which is 40. So again, when you're trying to determine an average speed, you do not average your speeds. You come up with how far you went and how long it took you. And again, you can use any distance you want. I just picked 120 here because it makes the problem easy because it generates whole number results. Our fourth trap is ratio, ratio, ratio. Oftentimes the test will give you a ratio of A to B and a ratio of B to C and ask you for the ratio A to C. Now again, the temptation is to just go straight from A to C. So in this problem, we have in Billy's marble collection, the ratio of red to blue marbles is 5 to 2. The ratio of blue marbles to yellow marbles is 3 to 4. What is the ratio of red to yellow marbles? Now if we write down the ratios, we have red to blue is 5 to 2, and blue to yellow is 3 to 4. And again, the trap here is they want you to pick 5 to 4. Why can't we do that? Because R is compared to B, and yellow is compared to B, which is blue, and B is not the same. So we need to make the number, the middle number, the blue term, the same. So to do that, we're going to treat this like a fraction problem, and we're going to get a common denominator between 3 and 2. So let's pick 6. Changing the red to blue ratio to 15 to 6. We haven't changed the ratio, we've just scaled it. Well, now we're going to change blue to yellow from 3 to 4 to 6 to 8. Again, it's the same ratio, it's just scaled. Now that the blues are the same, 6 on each side, we can take red to yellow as 15 to 8. So the answer here would be E and not A. So again, when you're given two ratios, you can go A to C assuming that B is the same in the two ratios. Otherwise, you're going to have to change the B's by basically treating this much like a fraction problem. Positive integer abuse is our next trap. This is kind of a fairly complicated concept, and it deals with proving things true or false. When a question like the one below says n does not equal 0, then which of the following must be true? It's tempting to pick one example and think that that proves it's true. One example can never prove anything true. It can, on the other hand, prove something false. So if you pick a number, you can start with the numbers, let's say 3. Be aware that that isn't the only number you need to try. And that's the trap here. People like to try only positive numbers. So if we try 3, we see that all three statements, 1, 2, and 3, are true. And it's tempting to pick E here. But we have to understand that n doesn't equal 0 allows us to make n a negative number. So if we try negative 3, statement 2 is no longer true. And as a result, we can cross out answers B and E. Now, it's another thing people don't try often is fractions. If we try the number 1/2, statement 1 will no longer be true. So having tried a negative number, a positive number, and a fraction, the only statement that is true all the time is statement 3, answer choice C. So remember, when you're trying to prove things true, one answer can only prove things false. So you have to try to find numbers, or I should say, numbers such as negative numbers and fractions to try to make the statements false. If you can't, then you can be assured that your answer is correct. But until you've tried negatives and fractions, you're probably under a false assumption as to what is always true. Our last trap is called count 'em up. It's a fairly simple trap, so we're hoping you can avoid it by just understanding it and being prepared for it. When you count up numbers, it's tempting to subtract when you count. So for example, if I said how many numbers, including 1 and 3, are there between the numbers 1 through 3? If you looked at it, you can easily see 1, 2, and 3, there are 3 numbers. However, you subtract 3 minus 1, you only get 2. So remember, when you subtract, you're going to lose one of the actual numbers. So if I said how many numbers are there between 1 and 100, including 1 and 100, many people would say 99. Again, because they subtract 100 minus 1, whereas the answer is actually 100. So in this problem, it says voters 1146 through 1167 must report to polling station C. How many voters are required to report to polling station C? So if we subtract these two numbers, we get 121. But if we remember the trick, which is we have to add 1, we know that the right answer is 122. So hopefully you can avoid these traps and not make the mistakes that the SAT is trying to make you make. Thanks, and see you next time.